So in this particular given, you have the symbol Fe, and the mass number on top is 56 and the atomic number 26. Let us check first the one below to confirm that this number is really the atomic number of the element. When we look at the periodic table and we look for Fe, which is here, so Fe, as what you have noticed, has an atomic number of 26. So this is the atomic number that I'm talking about. Let me just reiterate this because some of you might look at the numbers below. These numbers below, that's not a whole number, is not yet our concern, okay? So please ignore these numbers below. We stick to whatever is given in our formula for the mass number, which is protons plus neutrons. So for now, disregard these masses that you see below the symbol or the name of the element. We're going to go to these complicated numbers later on. But the most important information that you're going to get on the periodic table is the atomic number, which is on top usually, and it's a whole number, then the symbol of the element, and then the name. So for Fe, it is confirmed that the atomic number is 26. That is why the atomic number written here, or the number that's written below, is 26. So this is our atomic number. So the first thing, if you're confused about how to get information from this symbol, is label it. So 26 is your atomic number. And atomic number is represented by a capital letter Z. Because later on when you get to answer a chart, the chart will make use of symbols. So for you not to get lost, you put the symbol there so that you put the numbers at the right column. So this is your atomic number Z. So let me put a line there to indicate that's letter Z. And I know that my atomic number is always equal to the number of protons. Okay? And I also know that I am dealing with neutral atoms. Therefore, the number of positive protons is also equal, so this is also equal to the number of electrons. So these three are all the same. Okay? The next thing I'm going to label is the one on top. And I know that the one on top is my mass number. And mass number is symbolized by capital letter A. And capital letter A, the formula to get mass number is the summation of protons plus neutrons. So summation of protons plus neutrons. Now, if I will be asked to supply or to get the values of the subatomic particles, how do I do that? So let's list down the number of subatomic particles. So let's start with the nucleus. So what's the number of protons in here? Then we have the neutrons as well and the electrons. So you put equal sign. So let's find out their quantity. How many are they? So protons is, I see it here, which is equal to the atomic number. So all I need to do is copy 26 there. So the number of protons I have is 26. Because I see it from this symbol. Next is the number of neutrons. What is the formula to get the number of neutrons? I don't see it here, but I see it in this side here. So I know that the number of neutrons is just subtracting my A minus Z. My A is 56, so that's 56 minus Z, which is 26. So 56 minus 26, I get 30 neutrons for this iron here. And then for my electrons, I know that the electrons is just equal to the protons, which is 26. So I can just readily write 26. And then furthermore, if you're asked for A, you just also put 56 there. if you're asked for Z, then you can just put 26 there. And if you are asked to write what is the isotope with its name, so you see, you go to the periodic table, the name is Fe, the name of Fe is iron, so all you need to do is, the name for this isotope is iron, and then to indicate the mass, it's 56, so you put iron dash 56. And this is the representation of the name of the element dash its mass number to indicate that that is the isotope of that element.